Okay, we'll go ahead and get started. First submission was from Sylvie. Okay.
I really didn't know where to start. So,
Would you suggest ideas for areas that could use online systems versus all? I think you meant offline. Well, do I need trench drains in my design? Doesn't look like so. And how do I go about drawing it, but designing the system on AutoCAD? Because I see many examples, but don't know where to start. Start with the beam shaped. And the other one is how do I connect the newly added double contours on the system to existing contours? I'm not sure where exactly you're referring to.
it's like when, like an example is like 1007, and I think there's like maybe a berm in between, or like there's double contours. But I didn't know how to connect that and how that was drawn. I don't know how to draw it.
Double contours, do me here?
Like where the 5 is or whatever.
Here?
No, the where I wrote number 5, that little box area that doesn't look like a drainage area. The upper left.
Upper left. Here?
left.
5 here?
No, to the left further.
Further right
That-
here?
Yeah.
Okay.
I saw an example on the lecture where there's like 2 contours
Okay.
of the same number. I didn't know how that's drawn and why.
Okay, we'll take a look at that one. Then what should the system look like on my lower plaza? Just returning that, or should I have an RDI system? You actually would have a dispersion kind of sheet flow system there. Lastly, what errors people needing? Okay. So let's take a look. So you basically select like 2 different types. One, this is at the end of the system, so you would need a DR or an RDI. The other 2 you wouldn't, right? Because it's still along kind of one of the first in line. If this fills up, it continue to flow downstream, so you don't necessarily have to have an RDI. You can have it, but you do not have to have it. Okay. So I want everyone to kind of see what my process of drawing the cross section looks like, right? You have to understand the cross section to be able to grade this correctly. So so for instance, you here, you don't have a sidewalk. There is a variation later on, probably in the 3rd submission, we have a variation where you have a sidewalk and you have to have a trench drain and a curb cut. So that's a different cross section. And this one is one of the kind of simpler type where you only have a curve. So I would start by drawing the curb. I'll just draw here. Actually, I want a relatively white surface. Let me try to move it down here. So I would start with drawing the curb, and then so we're looking this way. Okay, we're looking this way. The cross section is cut. Let me move this over right here. Okay, cut right here, and then this south part is on the left and north part on the right. Okay, now we have a curb cut right here, right? The curb cut is determined by the contour on the driving aisle. This is 9 contour. You have it estimated at 8.9, which is perfectly fine. But you do need to get into details now. once you have, well, I can see some of your contours are still not finalized. For instance, this is not in the middle and not parallel, right? But this one doesn't really affect the calculation of your parking lot and driving aisle. So right now, if your parking lot and your driving aisles, the contours on them are fixed, you wouldn't change it anymore, are finalized, you should start calculating to decimal, okay? So let's suppose this one is 8.90 at the curb cut. Okay, and then this is where your parking lot, change to, that's your driving aisle. It's sloping toward, I'm exaggerating the slope a little, okay? This is draining toward your curb. And this is where your landscape is, you know, the kind of in the background, your landscape area, it's flush with your curb. Okay, but immediately, well, at the cross section of the curb cut, you should go down something like this, right? You're trying to design such a system like that, right? So you have your RDI set at 8.0, which means your RDI is somewhere here. Actually, that's the maximum water height. So I'm gonna use blue. So your water can only get to this point, right? So this is your RDI at 8.0. And let's plug in other information. Your LP equals to 6.5, meaning that here at the bottom, LP equals to 6.5, which means that your depth, the depth of the water is 1.5 foot. I would say that's a little deep, okay? So because you want to control the depth to 1 foot because of safety concerns. So that means you want to raise your LP, change to a different color. You want to raise your LP to 7. Okay. And then you have a 7 and 9, and that's too many contours. So this is a 9 contour. And the 9 contour goes there. That's correct. Your high point is 8.5, which is, your high point is not as high as the curb cut, which is okay in your design because you have an RDI. Okay, when folks don't have an RDI, it's a different story. Let me try to explain why that is. I'm just gonna draw your, so actually your, I hope I can erase this. Well, just redraw it. So that is your, so currently you set the high point here at 8.5. This is okay because you have an RDI. If you don't have an RDI, you cannot set this lower than the curb cut. Reason being, if I do not have another control of how high my water goes, water will keep draining from the 8.9 and it actually will overflow the berm there. Okay, so this is for everybody to note. If you do not have an RDI, your high point could not be lower than your curb cut. All right. So you have a 7 contour, you have an 8 contour, and the number of contours are correct. You do not need to have this line. So you do not have a boundary line for your bioretention. Okay, all the lines here represent the contours. So you would have a 7 and then an 8. Does that make sense? So no. So this line, you do not have a contour number attached to it. you only draw contour lines for the retention area. You do not have another line that's sort of in your mind, that's the boundary of the retention, but that's not, there's no physical boundary of that bioretention area,
I
right?
mean retention.
Yeah, in retention areas, you only draw the contours and note the RDIs, note the LPs, note the high points.
And bioretention is green retention areas versus retention areas are just like concrete, like cement.
This is the green area. Yeah, this will be vegetated. Okay. All right. So that's basically it. Now you get rid of the line that is the where I crossed it out. And you change the shape of the your contours to more organic. Right. Well, here it really depends on how big you want to be, right? You don't have a big drainage area from the start of the road to where your curb cut is. It's a pretty small, well, if you draw it out, it's a fairly small drainage area because you basically go from the curb cut and go perpendicular to contour, and this is your drainage area, right? You can see that's not too big. So that means you don't have to make it really big. But in the case you need to make it big, you could actually push this 9 contour. Well, that point stays, where it starts to connect stays. You could push it further, closer to the next one, as long as this doesn't exceed 25%. Does that make sense?
Mhm.
So that way you can make this big. You can make this that big. And that's essentially how you actually define how big you need it to be by pushing the other contours away and having this enclosure. Yeah, there.
I just was gonna ask is, how do you know how big of
Mm.
a shape or organic space, like, if we're making it organic, how do you figure out the exact measurement? Is it
You have the rainbow exercise. You're at this stage, you're probably not sticking to the rainbow exercise anymore, right? But your estimate is the drainage area 1/12. 1/12 of your drainage area. And then you could have a reference, you could have a reference, either circle or square. You put it aside, and then you approximate. You approximate the bean shape. It's pretty easy to do a list, right? To do a polyline, and then do a list to find out the area. Or you can just move your reference circle to the bean and say, okay, that's close enough. Once you do a couple, you would have, experience and saying, oh, that's close enough. We're not checking those numbers anymore. It's up to you to do the approximation. But Stu and I, we can, visualize, sort of visualize your final product and say, okay, that's definitely not big enough. Yeah. So not a precision calculation anymore, but use your square to estimate how big your circle or your bean needs to be. This one is a little different. Let's just change some of the numbers to see if they are actually in line with so you don't have an RDI anymore. For this one, we are at the 7 contour here, I believe. Yeah, that's the 7 contour. So for labeling the contours, you would want to label it more times than you currently have, because well, when we zoom in, we would need to know which contour it is so that we know, okay, the curb cut looks reasonable, right? And the curb cut right now doesn't look correct. Reason being, you need to estimate the spot elevation based on these 2 lines. Okay, so this is actually below 0.5. Does that make sense? So that one is 7. This is 6. You're probably at 6.45, something like that. Okay, let's just say 6.4.
Yeah.
So we will change this to curb cuts, 6.4 here. And then the bottom is, so your LP here, 5.25. And in this case, it will fill up to if you don't have an RDI, it will fill up until it's full at this level. Does that make sense?
Yeah.
Yeah. So this level means that you're also still exceeding the 1 foot depth. Okay, slightly. And then your HP equals to 6.6, that work. Okay, that works. So basically your HP is somewhere here. Well, we did say you want it to be 0.5 above your curb cut, just because, construction error happens, and then you do not want this one to be lower, kind of 0.5, lower than 0.5, higher than this, the curb cut. So this, you better put the berm at 6.9 there. Okay, that's a better design. So in terms of your contour, you have a 6. That's correct, right? You only have a 6 contour here. So that's this one. Okay, this one is okay. I'm gonna clear everything here and then move to the third one. So this one is at the end. You need to add an RDI. Okay, an RDI or DI, either way would be fine. And the curb cut, I believe you probably copied it from somewhere else, because this is below what? Below, let's see,
That was a
that's
mistake.
7, 6, and 5.
That must have been a mistake.
Right, this is 5. So if this is 5, then that is probably at 4.5, something like that, right? Curb cut at 4.5. And here, your water is actually too shallow because you only have 0.25. So how do you calculate this? Basically, you would do this, right? Measure that, right? Measure this and do 2%. And this is about halfway. So I feel this is actually lower than 4.5. Okay, this elevation, which means your water depth is 0.25, which is too shallow. Okay, so you need to pinch the LP down a bit more to kind of form the water depth as 1 foot. Does that make sense?
Yeah.
Yeah. So that's that. And this one is you need to add either an RDI or DI. Okay. Yeah. So if your high point is 5, you have a 110. No, contour works. Okay, the contour works, but no, I'm not exactly sure where your 5 is outside of the you have a 5, and then you probably have another 5 kind of going around. There's a back kind of, the line weight of the major contours and the minor contours are switched. So I know this is 5. So this is 5. And because of this, you need to change your 5 contour here, right? Very likely, this is where your 6 hits. See if this is your, yeah, that's your 6. And well, let me zoom out a little bit so that I can see where your other contours are. Yeah, that's right. Okay, you have a lot more room here than here. So yes, the 6 that's the original contour. It will be grayed out, and then your 5 needs to, let's just push, well, measure 25%, push this out to a point where you, no, that's not right, sorry. 5 is over here. Push to a point where you maintain 25% around here. You cannot change the 5 underneath, and then going out. You could probably move the 5 a little bit to the east side, so you can make this larger. Okay, so you can make this actually larger, where you have, let's see, you have more room on this side, so we can actually wrap it around. And then 6 is actually over here. So if needed, you can actually make it bigger like that. Okay, yeah, but no, make sure that I'm not conflicting with the 5 contour that in there anymore. So overall, I think most of the design is correct, but when you are not sure, start that cross section, and then you would be able to know, okay, no, I have issues here and there. That makes sense? Okay, so that is about the 3 areas. I know you have other questions about where I have to have, for instance, no, very quickly. Let's do, you can use this, right? You can use this, yeah, as a drainage. And you probably need at least 2 somewhere here, right? And then this at the end of the swale, I'm not exactly sure where your swale is anymore. Used to be here, but now it kind of switched in. Honestly, it shouldn't. Your swell line should not. You shouldn't have 2 of them.
Maybe I didn't switch it when we dropped the contours.
Well, I think it's worth spending a little bit time here. You have this. That's the original one. You have that one. Make sure they're parallel. You have, originally you have this line, I think. Well, let's see. That's your ridge line. And this is your original. Let's see, original goes somewhere here and goes somewhere here. Well, I think the grid, it's a little problematic. We need to try to fix that. Yeah, because you can see how distances are not exactly in the middle. Those look fine. Okay, these are fine. That one should go somewhere here. Yeah, this is where things went wrong, I think. You should have a contour here. That makes sense? It feels like the original contour is here. So this should stay. That should stay, right? And this should stay. And that should stay. This should stay. And
Contours?
because they're above the curve. This color needs to stay where it is, because this is where you did not draw. There's no curve there. Okay. And then this portion, you have it, that stays, so that's okay. So these contours are not exactly dropped correctly. Let's see, what's the purple here? Purple should be somewhere here. That's where the original one is. So I'm gonna draw with the other color. Those are the ones that should be on the, so that is correct. Okay. So we don't have another one, so this is a closed contour. That's a closed contour. No, sorry. This one goes out in the middle here. And this needs to be adjusted. That makes sense? Needs to be adjusted. That's the, let me number it again. 9, 8. Oop. This is the 7. That's the 6. And this is the 5. Yeah. The 5 goes out to actually this one. And you need to close the 5. So originally your contours were not dropped correctly, okay? So this 5 needs to close like this, so it stays with the other portion of the 5. And then this one continues out and then connect back to the 5, which eventually will hit this building, this wall. Okay, the 6 goes here. But once it's dropped, it's over here, and then it goes along the curb and then connect back here. Okay, that's your
That's where the line is. Down
right.
5 too.
That is the 6. So 5 and 6. 6 goes like that. And no, now you know this line was not correct. Does that make sense? And on this side, well, you basically have along the curve there.
I just have to move this swale line to where I draw
Right.
the contour.
The swale line remains where it was.
Oh.
Swale line, it's still here.
Yeah.
Okay, swale line does not go that way any. Okay. Okay. Let me try to make sure. Okay. Yeah, seems to be correct.
The drainage, the bioretention areas in between the drop-off areas, those need drain inlets, correct?
Come again?
The areas in the car and bus drop-off, do they
Mhm.
need drain and RDI? Because they're in the.
Yes.
center, like, we need those.
Yes, they need RDI. Yeah, they do need RDI. Okay. Kind of derailed a little bit. You need retention here. There. Cut some holes in the plaza would help.
For drain
Here,
inlets.
here you need a DI there, okay?
There's one.
Yeah, there's DI. It's better to make the screen. Now, if you can make the screen, would be good. Well, you kind of have to, because otherwise your water wouldn't be able to go out. And then a couple here, you already have it, so that's okay now. Yeah, you need to add things here, add things on this side, in the island, at the end of the swales. Okay, all right. Anything, oh,
And then
okay,
just
the back plaza? Back plaza. So you do need to try to figure out a way for the roof. Okay, does the roof go to the front or the back? Either way. You basically need just know a few lines. For instance, this one goes to the back, and then you would have 2 lines on the plaza down there and say scupper, okay, or trench, either way. And then you could have 2 retention just receiving water from those 2 areas, and they need RDIs because there's nothing downstream to receive the excess water. And then for these 2, you basically, if you are designing your contours just like, you have the slope just like that, you basically need 2 sheet flow, no curb, okay? There's no curb anymore, sheet flowing down here, right? Either 2 or 3. And this should be straightforward to design with RDIs, okay? RDI, because again, they're the end of the train. Okay, good. So I spent a little bit more time on the first one, just want to demonstrate to everybody how to construct that cross section. I might be a little bit more brief later on, okay? All right, I'll move forward to the next one. Is Amelia here? Okay, I am. Right. Is Amelia here? Okay, so I took a quick look at the submission. I'm not sure I can read the retention area. I know there are something, right? There are LP and HP, but I'm not sure how to critique without being able to read it. So the one question that I could answer is, where should this connect? You don't have a 1112 on the parking lot anymore. Okay, so your 1112 basically just goes along the curb. Okay, it goes along the curb and then connect to where, yeah, let's see. I'm trying to figure out where your 1112 was on this side. Well, zoom out again a little bit just to get. So a little bit of time. Yeah, I think this is sort of where all the lines start to split off without an ending there. You either need to go out in this area trying to connect the 1112 and above, or we can turn the contours here a little bit. Now, once we get to the driving area, we could start turning these contours so it will be easier to connect back here. Okay, I'm gonna make an attempt to do that. So you have 1111, 1112, we need, this is 10. And that's 11. And if we don't want to go too far into the neighboring land, we could do 13 here. I think that's 13, and then do 12 here. So basically we have a transition in this area where we have 11 and 12 and 13 states, and then 12 be here. And now the 12 goes here, connecting back to 12. I think this is 12. Let's see. 5, 4, 3, yeah, that's 12. 11 goes here, connecting to 11 there. No, that's 10, sorry. Connecting to 10 here. And 12 goes along the curb and then connects back into right here. Okay, that's how 12 goes. 13 goes where it is. Yeah, that's how you have, but 11 needs to go have some transition. That's your 11. Well, I think 11 was not correct in the first place. Yeah. Let's see. Yeah, 11, it's here. Okay. So there is a little bit of problem. And needs to be in the middle here. And then 11 comes down to here. Nope. Yeah, your 11 was not connected correctly before, so we'll have to look at this again. This is where 11 was. And this is where 11 is. Okay, your 11 is somewhere here. So let's change 11 to be coming out here and then turn. Okay, and then turn around so that your 11, the new 11, would be here. Okay, that's your new 11. Then your 11 could connect somewhere here and then back to the 11 over here along the curb, back here. And then that means your original 12 is somewhere here, and then come back to the 12 to here. But once we drop it, it should be like this, and then going along the curb, then coming out, and then coming across. Then your 12 goes like this. Okay, so that's your 12. And then 13 could be somewhere here, and you don't have to have a curb, so 13 can stay almost where it was. All right. So I want to go through this portion so that you are able to connect the rest of the contours, but you definitely have to seek out help for reviewing your retention area. I want to ask one more time, is Amelia here? Okay, well, reach out to me later. We should try our best to solve all the questions in class. All right. Moving ahead. I have Graham. This is a case where you have a trench drain here. So we would have a little bit of different cross section. And let me try to draw that cross section so you have a curve, but also you have a sidewalk. Okay, the sidewalk goes down, and the bottom of the sidewalk also goes down like this. And then once you get to the retention area, you do not have a curve anymore. Okay, so you get rid of the two lines here. You only have one line. Okay, the green area would just be, depending on where it's sloped, seems like it's sloping down. So this is actually your green area. You do not have another curve between your sidewalk and your green area there. Okay, so now the problem is that our curb cut is over here, meaning that you actually need to have something as a drain here. Well, this will, let's see. Water flows down. Water flows from the curb here. It needs to drop into a drain. Okay, makes sense? And then it actually flows out from here. Does that make sense? Yeah. So that means here you cannot use the elevation of this location as your curb cut anymore. All right. You need to drop for another 1/2 foot. Okay. So if your curb cut is, let's see how your curb cut, you need to calculate. Well, you could directly calculate from this location and to your nearest contour, but then you need to drop 1/2 foot. So if this one TC or BC is 1105.81, meaning this is 1105.81, here you actually have the bottom of trench drain equals to 1105.31. Okay, so this is where your water gets out. And then that's how you continue to use this as the reference elevation for your retention. Okay, so for instance, for this one, your RDI cannot be 5.71. You need to have your RDI be 1104, okay, 04.81, and so on and so forth. Does that make sense? Otherwise, let's see. Your bottom is, make sure you are under 1 foot deep, okay? And then your HP only need to be higher than this, no, half foot higher than the curb cut. Okay, so that's 1105.81. You have it at 6.25, which is perfectly fine. Okay. Yes, and if you have an HP above 6, you do have a 1106 contour there. So that's how you modify some of the numbers here. Otherwise, no, I can see that you understand the relationship between each elevations. Okay, good. Yeah, go ahead.
Would the trench drain be running along like the first parking spot?
The trench drain is only under the sidewalk. So it looks like this.
So just that. Okay.
Yeah, because you have a sidewalk there.
Mhm.
You once you cut a hole here, the whole thing needs, you need to have a drain underneath so that water can flow across the sidewalk.
Yes.
Okay, yeah. All right, so that's that. Okay. I'm gonna clear and see the other designs. You have another one, again, no double lines around the plaza, okay? And here you do not need a DI just because there's no curb anymore, okay? There's no curb cut, there's no DI. You use this as where the lowest point where water kind of concentrates and flow into the retention, which is perfectly fine. Just no DI, no CC or BC there. And your elevation is at about 6.2. That's fine. And LP fine, HP should be okay there. But for this one, you do need an RDI though. Okay, there's no DI, but you need an RDI. But I'm a little curious why you didn't combine this one with the swale one. I know, well, most of the water is clean. So I think you should basically just put this, at the end of your swell.
Yeah.
Does that make sense? Yeah, you do not need a,
That could be done. So how would that look?
will look like this. And then you can actually make it bigger by just having the contour and do like that. That makes sense?
Yeah.
Yeah. Yeah. So basically you're actually sheet flowing down from all these directions into your retention. And then you need to find out the lowest point where water enters. It seems like, yeah, this point and that point, they're quite similar. So you can base your calculations on whichever is the lowest one.
So would that be combining multiple bioretention areas?
It's not necessarily combining, well, all these the services are all contributing there. If you want to do something different, you wouldn't separate things here. You would actually cut holes upstream, right? Or put something here.
Yeah.
So that's how you more effectively separate some of the drainage area.
Yeah.
It seems like you were proposing a trench drain somewhere. It has a label here.
Yeah.
Yeah, you could have a trench drain going sort of across like this, right?
Mhm.
And then at some point, this trench drain can go, if you have room, can go in this place. Then you are trying to separate. If this trench drain, for instance, is this long, it's gathering water from this area. That's a big enough area that can go in a separate one. Okay? Yeah, so that's actually a pretty good idea. You are dividing somewhat evenly, this plaza area into at least two of them. And remember, some of these, you have a trench drain over here as well. It's not receiving a lot of water, you can see, right? This is only receiving this much water, so that little water, even if it drains into the parking lot, it's okay. You're not draining a huge amount of the plaza into the parking lot area. Yeah,
So,
so that one, I wouldn't think you need it. I don't think you need a trench drain over here.
yeah, so I can just indicate the drainage with the spot elevations.
Yes, yeah, yeah. Okay, so that's that. Let's see. Let's take a look at this one. I would say you can make this bigger. Okay, because you can, if we sort of delineate its drainage area, this can be receiving a lot of water. That much water. So that's how much it's able to treat. Okay, all this actually goes into the center grain. So for this one, you have a CC around 1107, that's correct. And you have 1106.20. They make sense. I think this one was okay. You have an RDI as well. So all look good. That look good. And what if you want to make it big, this is also for other people, we just need to keep these two connecting point kind of constant, right? We can't move these connecting points because it's determined by the curb and the parking lot design. But if you could curve this line, and then your retention area can be this big. Does that make sense? Or that big. So that's a way of enlarging it, in case you need it. Okay? All right. Anything else?
I made edits to the way that I had the drainage on the drop parking lot and area. I think that was in my questions. I wanted to ask.
Okay.
If that was like, if the changes I made were okay.
So overall, the annotations adequate. The annotations mean, you mean the trench drain in those annotations?
Yeah, just like labeling in general.
Labeling in general, I would say you could improve the placement of the labels. But all the required information are there. And the HPs, LPs, and the contours, RDI if you have them, TC, CC, BC, they're all there. For this one, you wouldn't necessarily have, because you don't have a curb here anymore, right? So you wouldn't have a curb. You would just say bottom. Well, you would have the surface of the sidewalk. Well, you don't necessarily have that one. You actually just have the bottom of the train street. Does that make sense?
Mhm.
So for this one, you actually have the TPD. BTD, bottom of the train street. That's how you indicate for this one, the entrance of the water flow. The other ones, I think we're adequate in terms of retention labeling. We'll need to look at where the PI and an RDI, okay. So you need a DI there, a DI here, don't forget, okay? And honestly, you need to cut through the sidewalk as well for your retention there, okay? You need to cut through, well, whichever direction, it's fine. Cut through these. And I'm not convinced this line is correct. Yeah, that's not correct. Originally, your 7, it's over here, your 6 is over there, but your 6 is connecting here. Well, you need to check the offset. I think your 6 is almost like, okay, that means your this, the slope here is a little off. Does that make sense? No, so let me erase some of the lines so it doesn't become so confusing. If your swell line is correct, which you were trying to have your swell line sort of squeeze through here, and it doesn't go inside of your parking lot, which was a good strategy, right? But if your your original 6 is over here, and you see that you do not have 2% slope, there's an easy fix, honestly. You could do something like this. Your 7 goes like that. Okay, this is your 7, roughly in the middle. Okay, this swell line's roughly in the middle, and then your 6 goes like this. That's your 6. Now your 6 contour, this is not correct. Does that make sense? Okay, I know you can make the changes afterwards.
We don't have an issue with offset.
Yeah, it's only in this area. It's a little skeptical where the 6 should go. Okay. All right, so that is the contour there. So far, I think you should edit your if we zoom out. Your contour label seems okay. Your spot elevations actually are not too small or too big. It will be, it needs to be around the size because later on you will have a lot more. You will have BC and TC, you'll get a lot more cramped. So I would not change the size just yet. I would work on the placement of it a bit more. The size actually look okay, both the contour labels and the spot elevations. You just need to use leader lines later on to try to reorganize them. It does take a bit of work. Okay. You have a question of deal with the curve at the 1106 and 1105 contour. I'm not exactly sure. You mean this area?
Like before, I didn't realize that I didn't need to do the curve on the other side.
Okay.
So I was
Oh,
just
right.
confused about
Okay.
that.
Okay. Sounds good. Anything else? Okay, I wouldn't think you need the swell, so you could get rid of them because water is draining mostly this direction anyway.
Mhm.
You do not need the swell here. Okay, can you see it kind of creating a little bit of a too complicated pattern here? You don't need to. Yeah. So okay, so that's it. Let's see. Next I have Alec. Is Alec here? Okay. So, I am looking for the retention area here. So you have a DI. The DI and BC, it's not correctly calculated in this example. The placement of the HP and LP is kind of all within the 1107 contour, so that's not correct. You have a sidewalk, right? Yeah, so you have the same issue, the same design as Graham just now. So that means the curb cut would need to be here, but then there needs to be a trench run across the sidewalk, and you need to calculate the bottom of the trench run out of the sidewalk. So the DI and BC needs to be determined by the distance to your 1106 contour. Let's probably call it 5.4 here. Okay, 5.4. And then you need to go down 2%. Okay, go down 2% and then drop 0.5. So my estimate would be if this is 10, 2%, 2, and 0.6, 0.8, so you are probably around 4.6 there, okay? So that means that the bottom of trench drain is 4.6. And then if we, kind of go back to the idea of curb, and sidewalk, and trench drain down here, and then coming out of here. So this bottom elevation would be 4.6. And once we are kind of out of that trench drain, you have a DI. Yeah, your DI would be at, no, slightly below this curb cut. And then let's see. Yeah, honestly, for this one, once it's once is full, it will be at about 4.6 elevation. And then your LP would actually be 3.6. So you're gonna dig a pretty deep hole here, okay? And we need to look at what's the surrounding contour elevation there. So you have a 6 over here, so outside you have 6. So that means you would have a 5 contour and a 6 contour in this area. Does that kind of make sense?
Yeah.
Okay. So basically you recalculate the curb cut, calculate the trench drain, the bottom of the trench drain, and adjust your LP and your HP based on the bottom of the trench drain there. Okay, so that's for this one. This is it's actually a complicated one. Let's see, we have a second one over here. So you have a 1108 contour. Is this correct? Some of the contours are running along the ridgeline, and that signals that's not correct. So we need to, well, your contour labels are definitely too small. Increase that size. So the criteria is that when I am grading the contour, I would zoom the drawing out like this, okay? And at this scale, or in this the print, in this print, I should be able to recognize the contour number in order to quickly see the big picture of which contours are correct or not. All right, so we need to fix this contour here. Let's see. It feels like this was yeah, there's something happened where we weren't able to kind of, I think it's probably the second, this purple section. It feels like this is the right contour, and these contour, they need to hit the wall, or they cannot stop at the end, kind of edge of the plaza, right? So this is the second one. And then that seems to go here, which is okay. I'm probably a little off there, that's okay. And then the next one, check if you have a little one or not, maybe not. So on this side, it feels like it's going like this. And then again, it needs to hit the building. Okay, so based on these two lines, we should be able to draw the dropped contour like this. And at this point, you need to turn, right? Because there is a portion of the contour that is on this. Now we need to go along the curb and then go like this. Does that make sense?
Yeah.
Yeah. And for this portion, it's a little more straightforward. You go from this and then go like that and go back up and now it's time to climb up here and that's your second part. All right, so take a screenshot of this one. It's recorded, but it's good to take a picture of this and fix this first. Okay, now I'm gonna clear. Okay, I'm gonna clear and then we'll take a look at this one. So I do need to know this is 8 contour here. Okay. This is 8 contour. Then if that's the case, your curb cut is actually higher than 8, right? You need to recalculate the curb cut again because this is higher than this one is higher than 8. All right. It's probably 8.1 and that's bottom of the curve. And you notice that your TC and BC has only a 0.04 difference. That's not correct. Okay, it needs to be 0.5. Okay, the curve is always 0.5 high. So the bottom curve equals to 8.1. And you have a DI is not inside. DI is when you have a dead corner. Okay, so here you actually need to label it as an RDI, as a raise drop inlet. Your DI is a bit low. It doesn't need to be so low than your BC here. Okay. And then your LP is 7.50. Again, if your DI is 7.65 and your LP is 7.5, you only have like 0.15 in water depth. That's too shallow. Okay. So for this one, I'd really encourage you to go back to the retention lecture. Retention lecture, there are different varieties of retention area that Stuart has shown how to grade. And I feel like the relationship between these elevations are not clear, okay, in this submission. And then you do need an HP. You do need HPs around here. Okay. So HPs needs to happen in this area. And then the curb cut always are determined by your parking lot contours. Okay, the parking lot contours. So you need to measure how far away this is to the nearest contour. And this is above 8, slightly above 8. Okay. All right, so that one needs to be changed. Do you have a third one? Let's see. 1, 2. Okay, that's the 2 that you graded. Some things that kind of caught my attention was your curb. Your curb is here, right? So the contours cannot cross the curb, right? It needs to, you need to find where exactly this is climbing up the curb. And yeah, actually it's here. Not really. Okay, we need to take a look at again. So regionally, that's your contour. And that's your contour. So, well, I'm not sure if it was me that was a little off or it was the ridge line. Okay, but doesn't really match that well. Can you see that? It doesn't really match very well here. So double check the lines if they're parallel. Okay, so once it's dropped, you actually have contours that goes here and somewhere there. I don't know if you have it. You probably don't have it. Okay. So if you don't have that portion, you basically just connect right here and then go up. Does that make sense? So it doesn't go along this on the plaza. It actually goes along the curb inside of the other line, okay? So that's that contour. Okay. All right, any other questions? We're good? I see a couple here. Parking lot berm. Not sure what you meant by parking lot berm. Can you clarify?
I was talking about the retention area.
Okay, I went through those. It's location of my train string, the right spot. I'm trying to look for. So you have a train string here, which is good, but realize that if this is what you want, your drainage area is this much. Still good, okay? That's how much you're able to treat, still good, but your train string needs to go somewhere, right? It needs to be discharged into somewhere, likely here. Okay, and then you need a retention somewhere here. But make sure that your contour, well, yeah, make sure you have room here. It seems like you have pretty limited room in this area. Maybe you fit it in between these two contours that you're trying to move. So not that one, but and then this contour doesn't really go, yeah, it doesn't really go along that plaza edge because there's no curb there. Okay. So let's think about the plaza design. This makes it quite difficult to connect contours over here. And you haven't changed all these contours in this area yet. In this case, you might want to think about changing your plaza. You know, I have a contour like this, and then my next contour could be like based on your original design, it's better, it's going something. Yeah, it doesn't really work that well. You could start turning here. Basically, you create a little ridge, sort of in this area. And then that when it comes off the curb, not curb, the plaza, it hits the wall here. And then this one, the next one, it's likely going to be there. You would have another contour here and needs to wrap around. And you can kind of see we are a little bit of, we need more space in this area to attach all the rest of the contours. So I'm trying to see which contour number this is. This, I remember this being 8. Seems like this is 8. And that should be 7. And if this is 6, yeah, we're just about running out of space there. Well, one way will be to make your plaza a little bit smaller. Okay, make your plaza smaller because you can see I have a huge, really flat plaza in this area. And I only can have 2% slope, right? That's why I am pushing my contours here pretty far away from each other, and it causes problems for connecting contours. No, 5, 4, no, all these contours. And if you make the plaza smaller, then these contour can start connecting back to your retaining wall early, right? You know, somewhere in this area you can come back. So I would say one way is to reduce the plaza size, and the other way, no, the other way is a little bit more bigger change. You could change your contour direction on your plaza like this, right? So that you would have contours in this way, and then you wouldn't necessarily have much difficulty in this area connecting contours. Okay, that's also an option, and I'll leave it up to you how to change it. Okay, so that's about the plaza. I do not see other trench drains, so that's okay. The other one, the swales, I just talked about the swales. Your swales are, I would want them to not go through the car turnaround. That ship has sailed for this side, but you can still change this side so that it doesn't, you can have the swell go like this on this side, okay? For the other side, you couldn't change it that much. You wouldn't do this instead. So I would say keep that one, but change the swell a little bit on the side so that the water doesn't really go into your turnaround area. Okay, so that's all I have for your submission. I'm gonna move forward. Okay, next one is Jonah. Is Jonah here? Okay. Let me take a look where your retention area is. You have a couple over here, and this one is it's graded, and everything is draining in this area. And for this one, I honestly will not put it here. I would put it at the end, okay, at the lowest point. The lowest point is where? Lowest point is somewhere here, which has the longest distance to the nearest contour, okay? So this will be your lowest point. That's your lowest point. And you need a D, oh, yeah, you have an RDI, so that's good. So let's suppose, okay, let's suppose your curb cut, it's at the correct, we'll just use this curb cut as the reference. Okay, you have a 7, so that is the 7 contour. It seems like your curb cut was calculated correctly. And you have an RDI, great, half foot lower and LP lower, good. You just need HPs, okay? So I don't know the contour number. What's the contour number here? The contour, you use the thick line, but that's the contour. That is actually the contour that is part of the retention. So you should change the line weight to either minor or major, depending on which contour number it is. Okay, so in this case, again, we do this thing, and then we go down to curb cut. Sorry, my bad. I'm just gonna move this up. Move it up. That's the curb that's coming out of the retention area. You have a 1106.29. And then your RDI is at 1105.79. And yes, that's correct, right? You have a 1106 contour, but not a 1105 contour. So it means this contour number is 1106, right? And you have another 06 contour on the other side, right? You have an 06 contour on the other side. So that means you need to have what? You need to have berms, okay? You have a berm that is above 6, okay? It will be 6.5. So what's missing here is your HP in between the two 1106 contour. Does that make sense? Okay. All right, so that's this one. Where's the other one? Let's try to find it out. Seemed like you did one of these. Well, the curb cut, you had it on the other side, but on the other side, it's not receiving water, okay? You need to have your curb cut on the side that is facing the water flow. That makes sense? So water is draining this way, and you wouldn't put any opening, for instance, on the backside, right? And yours is at the backside of the furthest point where water can drain in. Okay, the last one where water can drain in, you would do a tangent line, right? You would do a tangent line and try to, no, it's actually here. That makes sense? So that's the last point where water can drain, and you are on the backside just a little bit. So I would say you put your curb cut somewhere here. All right. And you can put one more somewhere there. This will be higher and that will be lower. So the lower one will define, okay, the lower one will define your water height. All right. Let's see about the calculations. And which contour number is this one? Is that 8? This is 8. Yeah, that's 8. So your curb cut, it looks like your RDI is a little high. That makes sense? Could be 7.8 or well, even lower, right? Than the curb cut. If the curb cut is 7.89 and you can do your RDI at 7.39. Honestly, you do not have to have an RDI here because water will just keep flowing down if it gets full, right? So readjust based on the new curb cut, the new RDI or no RDI, and then the LP will be, I would say 6.8, something like that, because now you only have about 0.3 in depth for this retention, right? We can do it better. Okay. I can see this is not correct. There's no DI here because this is not a dead corner, okay? Dead corner is somewhere here downstream, and here water will just keep flowing down. Does that make sense? Water will keep flowing down, so there's no need for DI in these areas because they're not a dead corner. Okay, so let's see. That's the second one. Your locations, you do not have to have this one because it's a pretty small area. You can start with that one. So 1, 2, 3, and that needs to be at the this will need to receive water from the lowest point, okay? And you need something here for the swell. You need something here for the swell. You probably need to break the plaza up a little bit, based on your rainbow exercise. And then retention. This area is not receiving anything. This area wouldn't be that much that useful. Yes to retention in this area. That's good. Honestly, you have a little bit here. Okay, if you sort of again draw your sorry, that didn't work well. Ridge line. Okay, draw a ridge line here. You have a little bit of water. Okay, you have a little bit of water that's trapped in, oh, change a different color. That's trapped here. Does that make sense? Well, let's see. Would actually, yeah, would actually keep flowing down. So that's okay. You don't have to cut a hole there. That's okay. Yeah, we'll keep flowing down. That's okay. Here we don't have to have anything. Okay, that's on the side. Let's take a look at the other side. Yeah, we need retention. We need retention on the other side as well. Okay, you need something here and there. Okay, that's the DI. Now coming out of the DI, it needs to connect to somewhere. So it could be shaping like this. All right, just gonna erase that one. You need one more down here because you have another dead corner. Okay, there is a lowest point that won't be able to drain anywhere. So you need another one here. These two can be combined because these two, well, depending on how much you have divided the area before. Okay, that's good. You have sidewalk over here. So, well, we might not be able to do it in the medium, but definitely on both sides, you can have two retention. Given the large area that well, I would say it's three here, okay? 3 on the other side, and one more here, and then one more for the plaza. Okay, one more for the plaza, and I would separate. No, I drew it kind of with overlap, but I would separate them because this is 30 water. The one that I'm drawing now, it's 30 water, and this is clean water. Okay, so those are the areas you need retention. Does that make sense? Okay. All right. Let me see if I missed any other questions. So I think I went through the retention location. Yeah, these valve retention is, yes, you need high points between that and the surrounding contour. And does this, okay, you did one more here. Well, depending on where the water come from here, there's no curb cut again, okay? This is a plaza. If you cut a hole, no, you wouldn't, unless you're doing a double wall system, otherwise you would not have a curb cut there, because this is your plaza draining down, right? And if you're cutting a hole here, there's a couple ways of cutting the hole. You could do something like this, which requires more area, but you wouldn't have a curb. But if you don't have any room, you want to keep it small, then you would have retaining wall of some sort. So it's called a planter. Okay, that's called a planter. And again, you would not use curb cut, but you would indicate the elevations using wall. So here you would have bottom of the wall, right? And then that's top of the wall. Does that make sense? You do not necessarily have to say top of wall here, but definitely you need bottom of wall there. Okay. So let's take a look at your numbers there. So the numbers are calculated based on, that's correct. And the LP is 0.94627. Let's see. Okay, this is 0.25 below. Well, only 0.15 below. And then that's, so your water is above 2 feet, above 1 feet. Let's keep it just 1 feet. And otherwise looks good. It's okay. Yeah, the numbers look good. It's just that CC is not CC. You basically just say 1096.42, okay? And then RDI, you pinch it down a little bit, because on the other side, you are only at 1096.35. There's not enough elevation difference between the lower side, the 0.35, and your RDI 6.27. Okay, I would actually just set it at about 1096, and then your LP would be 1095. All right. I'd say you need more. It seems like is accepting only, right? If that's the area you're designing, and if there's no like roof water that gets in, it's only treating this little area. Okay, So that's not enough. That's not enough. So I would say probably this would be mainly treating, the roof water. You have two of these treating the roof water. You have indication that these come from the roof. You could add the third one, that's okay. But you wouldn't have the CC anymore because you only would have these spot elevations at the edge, right? At the edge of the the rectangle box. You wouldn't have a curb cut, right? So you only need these spot elevations at the corner of this rectangular feature there. Okay, so that's that one. Anything else?
You have to draw that line into the drainage areas, lower plaza.
Draw the line from the roof?
Yeah.
You would, depending on how you design it, right? If you direct the water down
Yeah.
and then to a drain on the plaza, and then the drain directs to the retention, then you need to. But there are some kind of downspout. If you design a downspout and then the downspout pour into the bioretention, then you don't have to. But you only just need to indicate this is roof water. Okay, and you can without crowding the drawing, make it clear where it comes from, and then that's enough. All right, okay. You don't necessarily have to draw all the features that you design. Okay, so that's that one. Moving ahead. Victoria, I think. So let's take a look at this one. Again, I need to see the contours. So it seems like this is 8 and 7. Okay. If this is 7, I think it's really kind of close to 7. It's probably 6.9. And then you have an RDI 0.4. LP is correct. 106. Then 107. And then HP. HP is actually going to be here. HP is here. Okay, between 7 and 7. So HP would be 7.5. Okay, so other than that, things are looking good. That's correct. Here, you need to stick to wherever that's in the middle, right? So if I were to trace this one and then trace that one, I need to find wherever that's middle. Seems to be somewhere here. Okay, so your contour is actually connecting this line. Does that make sense? So I'm gonna just remove that one. So this point wouldn't change because this point is determined by your parking lot. All right, so that's that one. Okay. And this one, oh yeah, this one, you would basically, that's right. No, wherever, well, it's a little skeptical. Let's zoom out and see where the other contours are. Ah, that one is actually a close contour if that's the case. You don't have, right? You have this one coming to,
No, that one goes back, that one's 107, so that goes back left, like it curved around and then goes back.
I need to zoom out again a little bit more.
It's confusing, it goes like to the corner, across to the left, down, and then back up around the car drop off, and then it goes to where you were going.
So I'm looking for 7 here. Original 7, it's over here. And then original 7, it's going there. So this one should be 8. That one should be 8. And original 7, if this was the line, original 7 goes here. Depending on No, depending on if this is halfway, right? If this is less than halfway, then you have a closed contour there. Then that one seems, well, we're off pavement, so this one can go wherever because you don't have to keep that 5%, 2%. And this one is your 6. No, sorry, 8. 8 goes there, that's correct. So this one is actually it is a closed contour. This is a closed contour. Because it seems like this is less than, if this is less than 25 foot, then that's a closed contour. Okay. It doesn't really affect the design here. Now between your 7 and your 7 here, you still need 2 high points, and that's it. Does that make sense? Yeah, but you do need retention over here. So that will change the shape of your 7 later on. Yeah, your 7 would likely go somewhere like this. Yeah. Okay, so that is this one. Double check the distance. If it's less than 25, then you have a close contour there. Between the corner and the parking lot 107. Yeah. All right, so that's that one. Looking, should we be offsetting the contours in the retention area by 25? No. You are, oh, okay. In the retention area, you want to keep 1 to 3 slope. Okay, so well, by 4 feet, actually 25%, not by 25. By 25 would be 4%. You cannot have that gentle of a side slope for by retention, right? You can offset by 4. By 4 would be 25% and is allowable. The steepest you want to go is actually 3 to 1 there.
Can you repeat that? I'm sorry.
So are you trying to say, trying to ask how close these 2 contours should be? Yeah, minimum of 3 feet and go with the 4 feet would be good. Yeah. Okay, so little unsure about how to determine that one. So this is not on the swale. This is accepting water from upstream. And honestly, the one that you have here is not receiving a lot of water, okay, because there's no curb around the plaza. So you're receiving this much water, which is, well, some of these will drain into, depending on where your boundary is. So this is pretty small. If you want to make a feature like this more effective, you actually want to, well, let's see. Yeah, you actually want to make it elongated around the edge. So it will be something like this, right? So you want to try to capture from the edge, okay? All the water that flows to the edge, it kind of drains into the retention. Another way of doing it is using a train string along the edge, but I think that's not a really good solution for this one. You have a small, I would say a pretty small drainage area on this side of the ridge. So it's actually okay if you just sheet flow down, and having one of them is, no, it's sort of demonstrational. It's not receiving a lot of water. Here, if this is vegetated, you are basically dispersing, right? You're basically dispersing the water downstream.
Mhm.
So you don't necessarily have to have a retention area to do that. But it will be good if you have something. No, I would say it's not that it's not useful, right? It is still useful, but it's not as effective as we want it to be. We want something on the ridge line, no, sorry, swell line. On the swell line, basically meaning it's collecting all the water, contributing, upstream from upstream. So it will be more effective if put the retention here.
Okay.
Okay, put the retention along the ridge line there. Let me take a look at your elevations. So your HP is a little too low. Again, this is 8 contour. Okay, this is 8, and that is 7, and your HP is actually going to be on the high side with your the other 07. Okay, this is high enough. It won't, water would not be able to flow upstream. It's only when you have 2 of the same contour numbers, you need to prevent it from flowing downstream. Does that make sense? Yeah, so your HP should be between the 2 07s, and it needs to be about 7.5 there. Let's take a look at the RDI and everything. So my guess is just because the contour number was not correct, okay, that's why your RDI is pretty low. So meaning that you cut down a little bit unnecessarily deep into the ground, because water coming in from here or water coming in from along the edge, the lowest point is this one, right? Lowest point is this one, and it's about 7.4. And now our RDI just need to be like 6.9, right? 0.5 below the lowest point where water flows in. So 6.9 would be good. And here would be 5.9 for the LP. And yeah, you have a 6 contour and the 7 contour, and then the LP HP goes in this area. Okay, good.
Does that need a, curb cut? Not right?
No, because this is the plaza, right? You don't have a curb on the edge of the plaza there. Okay, so let's take a quick look at this one. Curb cut at 07. Good. And then RDI could be a little bit lower. LP can be lower, right? You can have up to 1 foot of water. And then you would have a 6 contour and let's see. Yeah, and a 7 contour. And this is the 7 contour. Yeah, HP is correct. So what you do not need is the 8 contour. I don't know. Yeah, you do not necessarily need so your 07 goes like this, right?
Yeah.
That's your 07. You do not have an 8 contour like you draw here. You just need a bunch of high points at 7.5. Does that make sense?
That you have like X's on, do I just take that out?
Yes, you have a 1107, and that's the only contour here. Yeah. Yeah, because your LP did not drop below 6, right? If you drop below, then you have another 6, but you didn't. Yeah. Okay, so that's that one. Let me try to zoom out and see if we missed anything. Yeah, I think we're good. Anything else?
Can you repeat what you said, like if the distance from the like 107 to the corner is less than 25, it's close?
Distance okay. So if this was your original grid, if this line was your original grid, you would not have, this will not connect back to the curb.
Okay.
This would be a closed contour. You would have 2 of the 107. Does that make sense?
Okay.
Yes.
Okay, great. Thank
Yeah,
you.
yeah. if this distance is longer than 25, then this line actually hits the curb and then it goes around like the other ones. But if this is less than 25, then your 07 is off the parking lot. Okay. Yeah, and it seems like that's the case. Okay, I'll move forward. William. Okay. So let's took a look at the you have a DI, you have 107. First thing that I caught was proposed contour should not be in parentheses. All right. No, remove all the parentheses here. But it's, you know, it's clearly labeled. The number, at least, it's really clear, so that's good. And based on the distance that I see here, I would double check. I would double check this number. I think it's around 6.4, but you should recalculate. No, I think the distance is longer than 50% of the distance there. Okay, so this wouldn't be 0.6. My estimate is around 4.5 or so. Okay, double check that number. So DI equals to 6.6. And well, your LP, so in this case, you only have 0.6, okay, 0.6 in depth. You can raise that because you're at the end of the chain here. So you have a lot of water to treat. Okay, so I would put LP at 5.6, okay, the maximum depth allowed. And after that, you have a, let's see, you would have a 7 contour. Yes, a 7 contour. And then that's it. You need LPs. Oh, sorry, you need HPs. My bad. I'm trying to find where your 07 went. Let's zoom out and see where your 07 is. My guess is your 07, it's here. Okay, so that confirms that your DI is actually lower than 06.5. So this is your 07, right? Is that right? And goes up like this. Yeah. So this confirms your DI is not 6.6, it's 6.4. Okay. You can see that your retention contour is conflicting with the 7 there. So you have to move your retention contour somewhere like this, and then going around and then go back to connect to the curb cut. If you want to make it bigger, well, I think there are some contours that are missing. We might be connecting to the wrong contour. Yeah, 07 should connect back here. If I'm not mistaken, this is 7. All right, and this is 6. Your 6 needs to go around and then 05. Okay, 6 I see connect right here. And 05 needs to go even further. Okay, it needs to go back to, well, we couldn't kill the tree, so 05 you shouldn't have this 05 here. We killed the tree that way, so 05 should just connect back here to the wall there, and 04 is adjusted, and 05 you probably only have a little bit of 05 connected like this. Let's see. Yeah, I think that's correct. All right, so there are some contours that should be fixed, and then your HP for this design, your HP will be in this area. Okay, between 2 of the same contours. All right, so just a quick recap of this retention design. You could not have have your retention contour conflict with your existing or proposed contour of 107. and double check the DI elevation and then add HP around, no, between the 207. All right, so that's a quick recap of what needs to happen with that retention. And you have another one designed here. DI would not be inside, okay? It's not inside. If it's inside, it's RDI. And curb cut is not at 6.00. It needs to be determined by the 706. So it's around 6.4. Your DI elevation needs to be changed. And your LP seems okay. RDI needs to be 5.4, something like that. And you need, for this one, you also need HP, okay, where we don't have HP. And you wouldn't cut your curb cut like this, okay? If you want to maximize water inflow, you would want to put it somewhere like this, okay? Both of them on the side to capture the water from your drainage area, which is essentially this much. Not a big one, but still, it's better to do something. Okay, so that is that retention area. Let me zoom out and see if you did another one. That's the two that I see. Okay. Where the third, well, you have a lot retention area to do. Okay. You would need a couple here, 1, 2. I would probably move this one over a little bit downstream. And then 2, and then 3, you capture this one. There is a dead corner over here. So you need to cut through, the sidewalk now to direct water into a retention outside there. And then you need something along the swell line for this side. But this side, the same thing, right? You have a couple, you need to design a couple over here. I'm gonna have to clear and then move the drawing, my apologies. And so for this one, we're on this side, you need a couple over here. You did this already, and you need something over here. We talked about in previous reviews. At the lowest point, you have to cut through kind of the lowest where water will pond. That's where you have this one. And yeah, I can kind of see, we are having a little bit of conflict here. The plaza also drains in this area. So what you could do, and I would still try to separate this water. So you would say, no, this one goes to a area to the left, right? And then you have another one here that intercept with the swale from the plaza, because this is dirty water on the left and clean water on the right. Okay, so those are all the areas that you design. Something for the roof and something for the back. Okay, something for the back plaza. You don't have a huge plaza. Well, but you could still benefit from splitting this plaza area into 2 by cutting holes or putting a trench in there. Okay, so that's this one. Anything else? Okay. Let's see. Tyler? You here, Tyler? Okay. So let's take a look at this one. Well, for this one, I first want to understand if it's for the drop-off area or if it's for the plaza, right? You would want to separate them. For the drop-off area, the lowest point is here. Yeah, it's actually a little hard to direct it. Well, you can still direct that out to here, but it seems your swell line goes like this. So you need another one for the plaza water. So I'd say one on the left side, kind of the same as the former submission, and the other one for the plaza. Okay, so both of them. And let's look at the numbers that you have. If let's pretend that this one is for the swell, okay? If it's for the swell, what you need to calculate is actually where water start to drain into the swell along the swell. What's the elevation here? Right, this is the elevation that you need to care about. And then let's see, if this is the 9 contour and we're at about 8, okay. Let's see, this is the 9 contour and that's the 9 contour, and you need to calculate this elevation based on the distance, okay, based on the distance to the 9 contour there, right? Let's pretend this is about 8, right? Yeah, pretend this is about 8 here, 8.0. And your LP is 7.3, that's okay. Your RDI cannot be 8, right? It cannot be 8.8, it's too high. Your RDI needs to be 7.5 instead. And then we need to look at where your 8 contour is, okay? Your 8 if this is the 8 contour, you would have HP of 8.5. You do not need 9 contour in this design. In this one, you do not need a 9 contour. Yeah, because your inflow is at 8.0. Okay, you do not need to make another berm around it that is higher than the surrounding. That's not necessary for this one. Okay, so that is this one. And let's see, is there another one that, okay, you had a couple more here. So I need to know the contour number again. This is the 9 contour, and that's the 8. You know, the BC apparently is too high, okay? Oh, no, too low. Sorry, this should be close to 8. You're at an 8 contour here, and your BC and DI here would be close to 8. You need to calculate, okay? Measure the distance from the corner to your 8 contour, and then get the accurate calculation of that DI, right? You have a DI at 7.5 and your LP equals to 6.3. I would say the depth is a little too deep. We're sitting at 1 foot depth. So raise that, okay? Raise that based on the correct DI. And you have a 7 contour. The same thing, you do not need an 8 contour in this case. If this is 8, that's 7. No, you do not need another 8, okay? You have a 7, and then you have an HP equals to 108, 17.5, and that's it. So for both of these, you have one extra contour there. So for that one, this is for the swell, which is good, okay? And let's see, what's the contour number? I really need the contour number to be labeled. 9, and this is gonna be 10, I think. That's 9. Let's see, and this is 8. That's a closed contour 8, and this is the let's see. That's the 8 contour. Sorry, this will be the 9 contour. If this is the 8, and then we have about 7.5 down. No, this LP is too low. Because again, you need to look at when water flow in at this entrance location, what's the elevation there? Does that make sense? If this is 8, we're at about 7.5 there. Okay, the entrance is at about 7.5, and your LP is about 2 feet below. You do not need that deep, okay? We'll set that at about 6.5, and that's better. Yeah, your RDI, you could set that at 7, and your LP could be set at 6. In that case, you would have a 6 contour, a 7 contour, and an HP 7.5. That's correct. So this one actually was right. You have a 6 contour and a 7 contour. So 2 lines there. Okay. And again, look into how these contours should be connecting to the wall. They don't seem right to me at this point. And your 5 contour actually killed the tree here, right? So those are the retention areas. Let's zoom out and see if there's any additional questions. No, if there is DI, you don't need RDI anymore. What should be between the pavement and retention area? You have a plaza, right? You have plaza, and no, you don't. The way you presented it, it's correct. But I would look into your line weight. I cannot see major versus minor contour at this point, and you wouldn't have as many. I would say it's a little too thick if it's a minor contour there. Okay. This is a good question, right? If there's sidewalk between, no, this one you should follow my review for Graham's submission where you have a sidewalk, you label top and bottom of train string. Okay. All right, anything else? All right, I'm gonna move forward. Is Jillian here?
Yeah.
Okay. So. We're looking at this one. And honestly, if, let's see, if Stuart has sort of said, this is a green, you could make this green. You do not need to make another one outside of the green here. You already have this one, right? So you could have a curb cut right at the corner here, and then another curb cut right at the corner there, because they are lower points anyway, right? So these will have DIs, and this is a lower one. So use this curb cut or DI to determine the water level inside the screen. Does that make sense? So you do not need a separate one here, okay? You need to use the lower elevation. Again, remember you need to use the lower elevation here to determine the water inflow elevation. And that's where you pinch, right? Pinch 0.5. No, if you have DI, you don't need to. Pinch 1 foot down, that's your LP. All right, and that's it. Because this is sort of an enclosed area, you don't actually need an HP. You just need an LP and then contours inside it. Okay. For this one, your let me zoom out and see where your swell is. The swell is actually along this line. Oh, sorry. Swell, everything is actually draining too. Well, that makes it even more important that you kind of cut this open. You might want to, let's see, that's not big enough. In this case, I would have, if you really want the sidewalk, it's kind of part of the design. Your sidewalk goes like this. Okay, goes like this, and now everything here is open. Beyond that point, this will be your retention area. Does that make sense? Yeah, so you stop your sidewalk. No, that's your sidewalk. You still have it, but you would have a trench drain cutting through your sidewalk. And then this whole thing would be your retention outside. Okay, so that's this one. Not convinced that we need that because, water is draining to that direction unless you have a trench drain of some sort and direct water inside. For instance, if you have a trench drain like this right here, then everything up this much will be draining into the side retention, and that's okay. If you want to do that. Let me try to look into the numbers. So for this one, you wouldn't have a curb cut, right? If we're doing a trench drain, like I suggested just now, like here, you would look at this elevation on the plaza, but also you need to look at the bottom, okay? Minus 0.5, but bottom of the trench drain is where water starts to drain out. So this is the surface of the plaza. That's the bottom of the trench drain. Okay, water actually flows out from here instead of there. So you calculate the plaza elevation, but you need to minus 0.5 to get to this elevation. And that's how you define your RDI. Okay, and you make it 0.5 lower. Your RDI could be 0.5 lower somewhere here. So this would be the cross section. And then depending on what's the next contour here, you would have a high point. Okay, high point at least at the same level of the bottom of the trench drain. Does that make sense? Yeah, okay. So this scenario will be a little bit more complicated. But just remember to push 0.5 down at the edge and then push 0.5 down for your RDI. And depending on what the RDI is, you will determine which contour you have in the area and look for, okay, within the retention, sorry, which contours you have within the retention and and then look for the same contour number with the surrounding contours and then add the HP between those two identical contour numbers. Okay, so that is this one. Let's see. Do you have a third one that you want me to look at? Let's see. So those are the two that are shown. Anything else you want to go through?
For my contours, I'm wondering when we have to change the contour at time if it's like a terminal surface and that. Are my contours direct on the side where the bus drop off is?
No, so far some of the contours are pretty problematic. We probably need to revisit the contours. So let's trace the original ones. This looks like the original contour. And then that goes like that, and actually it keeps going. And this looks like the next one. And that looks like next one. And then this, like next one. So these look like the original contour, and you will need to drop them just the ones that are on the parking lot, right? So this is the portion that is being dropped and needs to keep going and then needs to keep going like this. And whenever you hit the curb or you're in the vegetated area, that doesn't continue, right? The only portion that's changed is the portion that is in the parking lot. So those are the ones that should be changed. Well, let me go back one. If you cut through that one, it should actually only start like there. And then I think I am a little off in terms of my drop off, my offset, but you get the idea. So this one in the middle, and keep going, and then keep going, and then keep going like this. And then, and I suspect, well, suspect there's another little bit of this. Well, maybe not, because there is a swell here, so not for this one, no. Okay, so the purple, only those that are did not get, let's see, that stays, that stays. Okay, and this stays, and that goes out. And this will be connecting to where? To the drop the contour on the high side. So this is where it goes. And this portion would be actually going around, depending on how, if it touches it, okay? And then like this. Does that make sense? So this is gonna be the first one. That's the second one. So you actually don't have half contours, depending on if there's just a little bit of that. That could be a close contour as well. And then on this side, you're gonna be connecting like this. Does that make sense? Yeah. And then coming out of here. For this one, there's a little bit of this. But overall, you would go like that. And well, oh no, actually this continues, sorry. And this portion is not correct. Yeah, that's right. And then go down like this, and then go up like that. And this one would actually just go along the curve. Okay, so these are the contours that are dropped. You would have another one here, which is a closed contour. Basically, the brown colored, they need to be 50 feet apart. Okay, brown colored needs to be, so this one and that one 50 feet apart. If it's over 50, you know you have another one. Okay, and I doubt that this one is 50 feet away. Now, if I use the previous color again, it feels like that one should be somewhere here. Does that make sense? So I need this to be 50. Okay, so maybe just a tiny little bit over here. But it needs to, these two needs to be 50 feet away from those two. So this probably wasn't dropped correctly. Okay, same thing with this. This one is likely going to be somewhere here. Does that make sense? Yeah, so these are the contours. Okay, anything else? We're good? Okay. I think next one I have Marjan. Are you here? Yes, you are here. Can you unmute to let me know you're there? You step away. Okay, I'll come back to yours. Okay, I'll come back to yours. I'll talk to Matt first. Okay. Right. So let's take a look at this one. Should I combine this training spot with others near it? Well, you have, I would say you have a pretty spacious medium. So you would have multiple, right? You would have one here, You would have one here and probably a couple, 3 of them in the middle. And this is pretty big, so you are correct. The location of the CC is pretty good. You know, you understand pretty well that water wouldn't be able to get in beyond this point, so that's a really good sign. So CC here is, I'm trying to see what contour. Is this a 5 or I am a little confused about the contour numbers.
I think it is fine.
If this is 5, you wouldn't have a 5.5 here, right? Let's zoom out.
Yeah, it is 6.
This seems to be, this is 5. 10, 9, 8, 7, 6, 5. This is 5. Okay. There are some calculation issues. Yeah. If this is 5, you have actually lower than 5.5 there. You actually here, it's likely 5.3 or 4, okay? And this is 5.4. This is the lower one, right? Use the lower one to determine your RDI, which is good. I would push it down a little bit more. Now it's only 0.15 difference. You can push 0.5, okay? Your 1105 would be 4.65. If you have an RDI, you do not need a DI there. Does that make sense? Yeah. So
So should I cut instead of the
yes, that's right. Curb cut here. RDI 1104.65. That's your RDI. LP LP looks a little low. No, you keep 1 foot. Okay, you keep 1 foot of depth. And then there's no, yeah, after that, you probably won't have a 4 contour, but you would have a 5. And then you have HP 5.5.
Okay, so should the curb cut where the DI is gonna be, should that be its own separate retention area?
I don't think you need to. The reason being, the DI and your curb cut here, they're pretty close in elevation. So I would combine them, and they're pretty close in terms of location. When you want to separate is when you have the 2 different curb cuts at a really different elevation, no, half foot apart, then you would want to separate them. Yeah,
So, should I also combine that with like a curb cut on the, like that other side of that retent, like that, yeah, over there?
over here you have 4.8.
So,
Yeah, you would separate them. Yeah,
and then, correct me if I'm wrong, so the lowest point in the retention area is a foot below the RDI,
yes,
and then the RDI is half a foot below the lowest point of the curb cut.
exactly.
Okay.
Very good. Yeah. I would reduce the size of your cross. Yeah.
Yeah, they are there.
Yeah, they're a little too big. You would make it about the same height as your numbers there. Okay. Yeah, it will get crowded pretty soon. So we did that. Let's take a look at this one. Well, you did a parking lot one, which is great because the parking lot one, it's a different type we didn't go through actually today. Let's go through. The key for the parking lot one is to remember here is low. Okay, this elevation you need to calculate it, and so that you would know how low we're getting. So this is the plaza, and then we know, no, this is our entrance. This is the entrance, and you don't need a wall, right? Because you're basically a depression like that. Does that make sense? And now you can see the problem. We're pretty low here. So you can either put a wall here, just a little bit of retaining wall there to make it the water higher, right? Or you can make it really deep, then your water would need to be at this level. Does that make sense? So because this is a pretty small area, I would actually opt for the former design. So I wouldn't make it too deep. I would add a little bit wall here. Does that make sense?
And is that just like kind of like on the lower
Yes,
section?
yes. So you need a little bit of wall around here. Okay? And then you do need the bottom of wall, top of wall elevation
Yep.
for that. So let's quickly estimate it. 5 contour, and this is a 6 contour, and then this is probably 5.8. And you could pinch it down to 5.3, your RDI, okay? That's half foot down, and you have a 4.3 as your LP. And then this one will be about the same as this, so that's 5.8. Does that make sense? So your wall, the wall here would be top of the wall equals to 5.8. Make sense? And then you would have a 5 contour inside, and that's it. Yeah. So in this case, you wouldn't have, your HV is actually the T wall. So you wouldn't have a HP, you would have a T wall. And bottom of wall as well, because it's a wall, so you need T wall and B wall.
What would the HPs look like for the one in the
Yeah,
parking lot?
well, it's like this. one.
For the ones in the parking lot,
Like my the one we were looking at before.
beforehand?
Yeah.
Okay, let me clear here. Well, the HP here, you have it correct. Well, the number is not, number needs to be 5.5. Because this HP is between your 205 contour. Kind of makes sense?
Yeah.
Yeah. Okay, that's it. So those are the two. Where's this third one? Oh, here, you have a third one there. Good. So I would do the same thing as previous submissions. I would have the DI. Well, I guess it's okay if we're not treating the little bit. Well, not actually, yeah, we still have to treat this portion. Reason being, you cannot have just one curb cut over here. If you only do this much, a lot of water will go untreated, just go directly into the DI. This is this much water. You're only able to treat this much with this SCC here, and then you're able to treat a little bit additional with your green area here, but then everything in between there, does that make sense? All these actually goes untreated and gets into the DI. So I would say, let's try to do better. The DI is you're gonna look for the furthest point, right? So it's probably somewhere here. And given that there's quite a bit of work trying to cut through a plaza, I would actually just come up with a different design and say I do a curve somewhere like this. That's my plaza, and this is my retention. That's a lot easier than cutting through the plaza and direct water out. Does that make sense? So I'm just gonna do something like this. And then that's where water comes out. Okay? And let's suppose this is the correct elevations and all. CC RDI is a little too low. You can raise it to 5. And LP is okay. And you have a 5 contour, and this is your, let's see, this is your, that's 6, and 5 is down here. And HP, correct, No, these are correct. But I'm looking for your 5 contour and I think it's, let's see.
Yeah,
Yeah.
I had some issues with like,
5 needs to be up a little. Yeah, your 5 needs to be determined by the 6. You have a 6 over here, right? And you have another 6 over there, and you need to offset by 50. So your 5, if this is 50, your 5 at least needs to be here.
it's
Yeah.
40, but same concept.
Yeah, okay. So you're right, your HP will be in the middle. You have it at 5.9, that's totally fine. Okay. Overall, I think you did pretty well here. Let's see. Did you have a question about this one?
No, that one, you covered that one
Okay.
pretty well, and the only other thing that I really have is, how do we know when to choose between RDI and DI?
So there are places that you need RDI or the DI absolutely, right? Like this one, the location is not exactly correct. The location again needs to be the lowest point. You basically find the farthest distance to the nearest contour. So it's somewhere here. Does that make sense? So that's where you'd absolutely well, if you have an RDI, you don't need a DI in this either. So either an RDI or DI. But if you are not at the end of the chain, then you do not need DI for sure. If you are at the end of the chain, then you can choose either DI or RDI. Does that make sense?
What do you mean by change?
Well, for instance, if I'm here, there's nowhere to go if I don't cut it open, right? Yeah, so that means the area here, there's no way for water to flow elsewhere. That's the end of the chain. This thing is the same, right? If I'm at here, if it's full, then water just keep flowing. Does that make sense? So that's not at the end of the chain.
So that one could be a DI.
This one,
or-
so this one, it don't have to have anything because water will just keep flowing downstream. Yeah, if you have a retention over here, you don't have to have a DR or an RDI. But here you need to have a DR or an RDI because otherwise water have nowhere to go.
Okay, so we only need either one if it's at the end of the chain.
Exactly.
Okay.
Yeah. Okay. We're good?
Yeah.
Good.
Thank you.
All right, no problem. Okay, let's talk to, I think this is Janice. Janice here?
Wang,
Yeah.
sorry, I'm here.
I called,
Imagine, but
we'll talk about yours. Okay. So you have a system here and well, for yours, you need to, I'm not sure if you heard kind of when I was going through grams. That's the third submission. Here, we need to go across the sidewalk. So it's not a curb cut anymore. I'll very quickly illustrate. So you have a curb and this is the top of the curb and you start cutting through, the curb cut is over here. This is your sidewalk, okay? Now, if you have a sidewalk, once you cut this curb cut, water needs to actually flow in a drain at the bottom across the sidewalk, okay? Otherwise, you wouldn't be able to, you have to have something at the bottom to direct the water across the sidewalk. So this is the edge of the sidewalk. So what you need to do is not just to calculate on the surface what this elevation is. You need to calculate at the bottom of the trench drain what the elevation is. Okay, so you need to minus 0.5 to get to the bottom of the trench and use that as your entrance elevation for your water flow. Okay, so this is, well, let's suppose we're just, minus 0.5 here. BTD equals to 1105.94. So that's our bottom of the trench drain elevation. I'm gonna clear some of these. Your RDI is 105. No, that's okay, but you can set it at 0.44, okay? 5.44. And then your LP looks good. And you have a 5 contour. And you have, let's see, you have a 6 contour, so you don't need the HP, so that's good. Yeah, I think you have an additional 6 contour. That's not necessary. The reason being, we have lowered this ground down because of the sidewalk. That's why you do not need an extra 1106. Oh, in this case, you do not need HP. Okay, so so only 1106 on the outside of this would be fine. Because we lowered the whole thing because of the trench drain. Okay, so that's that one. For the one next to it, I'm a little, I don't think it's at the right location. You should put this retention right on this. No, you need the connection with the swale, okay? Because you are trying to receive water from the plaza. All right, so you could make this a little bit smaller so that they don't get into each other based on, well, but you do need to base that on estimation of the area, okay? So this one needs to be on the swale so that it will receive all the water from the plaza. And then the elevation will be determined by where the entrance elevation is. So seems to me a little low. Well, let me double check. So this is 7. And based on its location, your elevations are all good. Okay, if it's placed in this location, your elevations are good. But I'm not sure that's the location. So when you make the adjustment, you need to know the elevation. For instance, here, that would be 1106. Then your RDI will be a little bit lower, okay? And then the LP will be a little bit lower as well. But the relationship you have here between all your elevations, that is correct, okay? All right, let me try to take a look at this one. That's the third one. I'm not seeing the curb cut here. So you do need to specify where your curb cut is. And your RDI, not most likely, definitely. Okay, the RDI definitely is too high because the curb cut are lower than 1108, right? Your RDI will be lower than your curb cut. So it's not going to be 1108. So for this one, you need to first find your curb cut elevation and then minus 0.5, that's your RDI, and minus 1, that's your LP. Okay, that's how this one should be modified. All right. And I am pretty sure that there's something, okay. Your 1107. Your 1107, oh, sorry. Or there's a 1108 in the middle somewhere. This is 108. And I'm not convinced you need another 108 because I mentioned this is lower. Okay, this is lower than what you have now. I don't think you need to build another 1108 here. All right, because the retention area is on this side. Okay, on this side, and there is a berm. Okay, let's see. Your 1108 itself is the berm that is kind of preventing water to flow downstream. Let me think. So that's the curb cut. Curb cut here. And then this is the other curb. Well, you just need to make sure that this curb, okay, make sure this curb is higher. If the curb cut is somewhere. All right, I know where I drew it not so well. Let me change it. So, oh, curb cut is likely at 107.5. And then this curb is at, the top of the curb is at 1107 point, let's see, 94, 1107.4. Yeah, that's about right. So the curb is a little bit lower than the curb cut there. Yeah, so then you're right, and you have to have a berm in between. That's correct. And this is you have an 08 contour here. So that means, why would you? Oh yeah, this is an 08 contour rounded. Okay, I take it back. You are correct that you need an additional one, but the thing that was wrong, okay, the thing that was wrong was actually how it was attached. Okay, you need to have the first one attached to, this one needs to attach to the middle. So that's the original 08. And then you have another one inside. Okay, because the 08 was the one that is coming from the dropping of the parking lot. And then the other one was what you created. Does that make sense? It's a little bit confusing here. Well, I will assume that it's good. Okay. So I went through all the three. Anything else?
Sorry, I'm not sure how much should I have, how many actually should I have by retention in all over this site?
You need to have at least 1, 2, 3. And it's good if you have something here. It's good if you have something here too. And then on this side, you would have 1, 2, 3, and then out of this lowest point there. Better add one more because you have a lot of water coming down here. So those are the locations where you definitely need to design retentions. Okay.
Okay, and what about the ones that I have now on my plaza?
This is good, but I'm not sure about that one. This one, it's kind of kind of conflicting with your sidewalk now. So I wouldn't put it there. I might move it to the side a little bit downstream somewhere here. And you can incorporate a trench drain. Well, in fact, this one, yeah, I think a trench drain would be good. Just having just one line that across the plaza, you're actually going to treat all this water. So that's significant. That makes sense?
Yeah, thank you so much.
Yeah, all right. Cool. I have one last student. Is Janice here? I think I pronounced the name correct. Oh. Well, if not, let's see. Okay. I guess, if I will go over the submission if Janice is here on Thursday, okay?